This short tutorial video will explain you how to set up RAPCAM to cut this complex path on doubly curved surface. And basically you can see here what we have is as an input is just a surface with a path that goes along it, and the robot is always pointing to the normal of the surface. The script is split in two parts. Basically this one sets up the input planes that are sent to RAPCAM components, which solve the orientations of the robot and generate the instructions. So this part generates the planes, this part generates the tool, and then the solution is of course here, where we just select the robot of RAPCAM, one of these components, and then KUKA instructions, because it's a KUKA robot, will generate the code which you can emit via panel to the disk and put to the robot, while this component is a robot position solver component, will basically analyze the tool, the robot, the planes, and the parameter which represents the path point, normalized path point on the surface where the robot needs to be oriented on. And it gives out, of course, geometry details like meshes, planes of the joints, and TCP plane. We don't see it here, but you can extend other components on top of those outputs. So, let's get into more detail. First of all, of course, if we move the slider, we'll see our robot moving nicely along the path, and you can go through all the positions on the path to check if robot doesn't collide with itself, etc. So you see this is quite a complex geometry with quite a complex path, but at the end it comes down to being able to define those planes and send them to RAPCAM. RAPCAM will interpolate all the orientations between those planes and suggest the best possible outcome for the robot on all the parameters that are possible. So even if the density of the planes is not big, this will decrease the accuracy and resolution, but it won't affect the RAPCAM's possibility to interpolate. And we can demonstrate that through, so now we have the curve which is split into 2000 parts, but if we split it into 5 parts, of course this is a really coarse resolution, and that means that we have only 5 points on the path. This will decrease the resolution of the simulation, but the robot will go from one orientation to another by following the polyline basically and orienting to the normals when reaching those points. So let's set it back to 2000, because if you want to have a good accuracy, that's the resolution you need. You need a minimum this sort of polyline to be followed by the robot. And so you see already that, okay, first we divide this in 2000 parts, then what we do is we identify the normals, we create the planes on the normals, and then we align those planes on one master plane, which is just first in the list, and this makes the robot orientations a bit more stable, otherwise the planes may be facing different directions, and yeah, it will move the head around more. And here, of course, standard tool creation. So we have a mesh, of course, with a milling bit, which is given to this tool component, and then we have all the TCP information set up, which is not something we'll dive into in this tutorial. We'll dig into this in some future videos.